Now we're going to work with piecewise functions temporarily. So to evaluate them, we need to determine which piece the given x value fits into and evaluate into that piece only. So here we have this function, h of x, and it has three branches, negative 4x minus 20, but that only applies when x is less than 7. Then we have second branch, which is a constant of 1, and that's whenever x is between negative 7 and 1, not including 1. And our third branch, x plus 9, and that only applies whenever x is greater than or equal to 1. So for part A, we have h of negative 9. Well, negative 9 is less than negative 7, so we're going to use this piece of that. So we're going to evaluate this in negative 4x minus 20. All right. Negative 4 times negative 9 minus 20. Well, that would be 36 minus 20, or 16. So h of minus 9 is equal to 16. Part B, h of negative 4. Well, negative 4 actually lines out with the second branch. It's between negative 7 and 1. So our value is just 1, constant of 1. Part C, h of 1. Well, 1 doesn't agree with the domain here for the second. It's this one because it's included. We have greater than or equal to 1. So we'll use the third branch. This would be x plus 9, so that would be 10. So h of 1 equals 10. And then for the last one, h of 3. Well, 3 is greater than or equal to 1, so we again will use our third branch, which is x plus 9, so that would be 12. h of 3 equals 12. Now let's see if we can graph a couple of piecewise functions. So when we do this, we want to graph by creating a t-chart for each piece. Choose at least two x values where one or more are endpoints. We want to make sure we check what's happening at the endpoints. And as you graph, decide whether the endpoints of each piece should be open or closed, or possibly arrows. Open circles match up with the less than or the greater than symbols, and closed have those included values. So our first function is f of x equals, we have x plus 1 for x less than or equal to negative 5. Second branch of negative 3 for x between negative 5 and positive 6. And 1/3 x for x being greater than or equal to 6. So we're going to make a t-chart for each of these. So let's just see the x plus 1. Just use that. So x plus 1. I definitely want to use the value of negative 5. And since this function is defined for less than or equal to negative 5, I can just do negative 3, something like that. So if I add 1 to each of those, that would be negative 2 and negative 4 respectively. So I'm going to graph those, negative 3, negative 2, and negative 5. I shouldn't have done that. I picked a very bad x value. Let's make that negative 6 instead, so that it lines out with that domain. So that would be negative 5. There we go. See, I caught that because I noticed that my domain was off. I need to be to the left of negative 5 when I work with this. So negative 6, negative 5. Negative 6, negative 5 would be right here. Negative 5 is negative 4. And at that point, it is less than or equal to, so I should have a closed dot there. And this is valid for this end of my domain. And it continues going that direction because it's just less than or equal to. Okay, everything less than negative 5. All right, the second of these is a constant function of negative 3 from 5 to 6. All right, so I'm going to go ahead and make a t-chart for this. But no matter what my x value is, my output's going to be negative 3. So at my endpoint of negative 5, that's negative 3. At 0, it's negative 3. And at 6, it's negative 3. I'm making sure to use my negative 5 and negative 6. Right. Now, both of those are open dots because we don't have an equal to with either of those. So negative 5, negative 3. All right, and then my endpoint of 6, negative 3. And then 0, negative 3 is right here in the middle. So it's going to be just connecting those three. Now, making a t-chart for 1/3 x. I'm going to choose values that are multiples of 3 so that I don't have fractions or decimals as my answers. Let's start with, well, my endpoint is 6, so I'm going to use 6 first. And then let's say 9. All right, well, 1/3 of 6 is 2, and 1/3 of 9 is 3. So I'm going to use those points, 6, 2. And this is an equal to, so it should be closed. And then 9, 3. And it appears to continue in that direction, and that is a linear function, so I'm going to connect it in that manner. All right, let's look at another example. We have two branches, f of x equals 5 for x greater than or equal to 1, and f of x equals negative 1 minus x for x less than 1. Now, first one is going to be a constant, so even though I'm going to make a table, beginning at 1 and say 3 and 5, my output is just going to be constant. And that's for greater than or equal to 1, so it's going to the right. So 1, 5, and that is a closed dot because of the equal to. 3, 5, 5, 5, it's just going to be 5. Now for the second function, make another t-chart. Okay, and I want to start with a value of 1, even though it's going to be an open dot there. And let's see, something less than 1. How about 0 and negative 1? So at 1, if I evaluate that, that would be negative 1 minus 1. That would be minus 2. Plugging 0, and I get minus 1. And that would be negative 1 plus 1. So that would be 0. So I have 1, negative 2, but that's an open dot. 0, negative 1. 0, negative 1. Negative 1, 0. Hold on a second. Less than 1. So 1 is negative 2. 0 is that. Negative 1 is 0. I put that point in the wrong place. That's what it is. All right, try that again. 1, negative 2, open dot. I have negative 1 and negative 1, 0. And that continues in that direction. Something like that. Now, I'd like to point out that I actually like sometimes making mistakes. Sometimes I do it intentionally, sometimes not. But I like making mistakes to show you how you can think through when you make a mistake like that.